think we're good. I'm going to go ahead and start this, and we're going to show you how today. I'll show you how to put this into our 3D printer program. As you can see, I already created the drawing. I've already saved it as an IPT file on my network drive, but I do need to make a file that I can use in the Ultimaker. So I'm going to go to File. That's where we're going to start things off. Go to Export, and we're going to go to CAD Format. There. And what I need to do is bring this window down here and scroll until I find STL. And before I do that and hit the Save button, I need to hit the Options button and just make sure that my format is binary millimeter units. Okay, those two things. And then resolution is high. And we're going to just say OK, and I'm going to save it. Now this file, this STL file, needs to save in your network drive also. So that's where you're going to go with that. Okay, mine just says to replace it. Yours won't say that unless you're saving it again. So once you've exported it as an STL file and you saved it as an IPT so that you can edit it if you need to, you're going to go to Cura. Now Cura on my machine is at the bottom. You're going to type in, go to this little search window and do CUR, and it should come up with Ultimaker Cura 581. And then you would just click that and start the program. I'm going to click mine here and start my program at the bottom. Yours won't be there. So you have to do CUR, and it should bring up Ultimaker. Excuse me, Ultimaker Cura. All right, so this is what the base of my 3D printer looks like. We're going to set some stuff up here before we even get to bringing the part in. So I'm going to just close this window so it's out of the way, and I'm going to kind of go through the process to show you what you need to click, because this, if I'm not mistaken, is a little bit of a difficult thing to find. We don't have an Ultimaker printer. We have what's called Creality, and we're using the Creality Ender 3 V3 KE. Let me show you how you get there. So we're going to drop this window down. You're going to click Add Printer, because I don't think the Creality is going to be there. So you're going to click Add Printer, and you're going to go to Non-Ultimaker, and we're going to go to Add a Non-Networked Printer, because the program still needs to know what machine we're using. Ours are not on a network. It would be nice if they worked. We could just send it, but they're not. So we're going to add a non-networked printer, and then from there, I believe if we pop this up, because that it probably will try to do an Ultimaker printer. If we scroll down here to the E's, it should be here somewhere. Oh, wait a minute. Hold on. Maybe it's not E. Now that I'm thinking about it, it's probably in Creality. There we go. Yep. So Creality 3D is what we want. And once you select Creality 3D, you're going to go all the way here until we see the Ender. Right there it is. Creality Ender 3 V3 KE. So you're going to click that and say Add. And that will add your printer. Now, there's a bunch of different settings here. However, what we're going to go with when we start this is actually a reset. So I'll always reset the printer. So you're not going to mess with any of that stuff. It should already be set up to go. So we're just going to click Next, and that should load it in there. Now mine has a number 2 listed there. Yours will just have this one here, the one that I'm highlighting with the mouse will be there, okay? The next thing we need to do is set up the plastic. So the plastic could be a different color, but it's always going to be the same type of plastic. So we're going to use this window. If you drop this down, and essentially what you're going to do is select Generic. And then once you're into Generic, you're going to go to PLA, and you're going to select that. And the nozzle size is perfectly fine the way it is. So that's how you're going to select your plastic. So when you're done with your selection setup, you should have this printer listed. Oops, sorry, hold on, let's go back to the right one here. This one, Creality Ender 3V3KE, should be listed if you followed the instructions. And you should have generic PLA with a 0.4 millimeter nozzle. All right, so there's that. When I go to load the part, there'll be some additional piece of information that we have to sort of select here. But I think that's good. I think if you select this stuff, I'm quite certain. I'm just going to kind of go through a real quick switch up here. Okay. So we're going to discard. We're going to discard the changes. Yeah, so when you go in here, you go to generic, go to PLA, and it should be good. It should be all set. If the window that just popped up pops up and recommends changes, you can go through that and just hit OK. I don't think it's going to do that because I had changes made, but you may not experience it. But anyway, you go to generic and PLA. All right, so we're good there. All right, so the next thing is how do you move that bed around? If I hold the right mouse button down and I move the mouse around, I can kind of flip this around, but that's not kind of really relevant here. We need to load the part. That's the next thing we're going to do. So I'm going to go to File and open the file. And in your network drive, you should have saved your STL file. So I need to find my STL file, and there it is. Okay, so it's not in the right position. So before we do anything with the actual quality control of the print, which is we're going to have to fiddle a little bit with that also. We need to set this up so that it'll actually print. So if I hold the right mouse button and I rotate this up, I can see there's a lot of red here, and this is by using the wheel on the mouse. I can get closer. This part here in particular is no good, right? There's just a little light blue there, and that isn't going to work. We want to position this so that the printer will have an easy time of printing it. So your stuff that you made also may have to have this happen where we rotate it so that it's sitting in a more natural and stable position. So I'm going to show you how to do that. Now let me just back out a little bit here. I'm going to click it, and you'll see that you end up with your three axes. Okay, so this is basically up and down, back and forth, and side to side. But we're not there. What we're going to actually do is, and I'm going to rotate this by holding the right mouse button down just so I can kind of see it from the side somewhat. I'm going to actually go to this thing called the rotate button, and I'm going to select that. And you see now that you have you can rotate this about the axes. So the axes aren't there anymore. And what I'm going to do is I'm going to actually grab the red arrows here, and I'm going to start by clicking left and dragging. You can see 15, 30 as I drag it with the mouse, holding the mouse button down, and I'm going to keep dragging it until it turns to 90. All right, and then I'm going to let go of the left mouse button, and it should plop it down onto the surface of what's going to be our printer. And then I can go back and click on the move button. So I'm going to go back and click move, and that should return me back to having my three axes present. And now I'm going to just right mouse click and rotate, and what I need to see here is that it's blue. Almost all of it's blue. There's a little section here I'm a little concerned about with dark blue. Now dark blue isn't bad. It doesn't mean that anything bad is going to happen. It will print just fine. So I wouldn't worry too much about that. And you can see there's a red section here, but that's okay, because if we look at this from this view, that red section is a part that's hovering above the surface. So of course, naturally that would be red. You can also see there's a little red here as well. Those are okay. Now I'm just going to check it by grabbing on the blue arrow. I'm going to bring it up and let go. Left mouse button, release, and yeah, we got a lot more dark blue now. So that's kind of an interesting situation. What I may do here, let me just zoom out, and you'll kind of get used to how this actually functions. Took me a while to kind of understand how it worked. There we go. So I moved it around the surface a little bit, and then I picked it up and dropped it, and now it seems to want to do that again. So I'm going to just try different places here until I'm happy. Yeah, it's off the side. No, it's off the printer. That's why I did that. There we go. Okay, I'm not going to mess with it. Not going to mess with it. All light blue. So I'm good with that. I'm happy with that. All right, so now I can go in here and I can make necessary changes. to make sure that this thing successfully prints. So yes, I'm not going to put it centered on the bed. It doesn't have to be centered on the bed. We're making one part here, so there's plenty of space for the printer to operate. And we can kind of drop this window down here, and we can kind of go in and change things that we're interested in changing. So one of the things I'm going to change here is the printing temperature, and that is the head of the printer, the actual printer head, and that's what melts the plastic and allows it to extrude and print. And I'm actually going to just bump that up to 210. So I'm going to go in and change that to 210. Now that's Celsius, by the way, so Fahrenheit is quite a bit more. And the build plate temperature, I'm actually going to increase that to 65 degrees. The spools of plastic, and I'll kind of go into that today, they have like recommended settings that you can use. I want to make sure that, you know, I'm a little bit above the minimum for printing with PLA. We're not going to mess with speed and travel and cooling. Support is, I should be okay. I'm just going to give it a little check here with that. Yeah. Yep. Okay, so we're good. So we're not going to mess with that either. There are other things that we can look at here, though. So, like if you click on the quality, you can actually change. There are tons of things you can change within here. But again, we're going to leave this alone. Quality is okay. You click on this, it'll talk about the walls of your design. We're not really too concerned with that either. And then we have a top and a bottom, so you can mess with the top and the bottom, including the different types of layers and top thicknesses and things like that. It's kind of impressive. We are going to change one thing, though, here. Within our extended print settings, and that is going to be how we do the infill. So we want this to be kind of, I guess, if you will, like kind of tougher in terms of the infill. And so we want to kind of watch for the types of infill that there are here. And I think if we click that, we can just see that there is an infill density of 20%. That's pretty good. We're actually going to just bump that up a little higher. So I just click this little arrow right here for that. We want that to be 30. So we're going to go with 30%. And we're not going to use cubic. We're actually going to see here, there is one that we need to use called gyroid. Gyroid is going to make this super strong on the inside. So there's that. Right. I'm thinking wall thickness is 0.8 millimeters. That should be good. Top and bottom 0.8 also. So we're good there. Those are things to check though before we slice this. So I'm just going to hit walls. It should be 0.8 millimeters. That's our thickness. And then if we go to the top and bottom, that should be the same. 0.8 and 0.8 is what we're after. Top and bottom thickness right there. So 0.8, 0.8, 0.8 all through there is good. I think we're pretty much ready to slice this thing. I don't think there was anything else that I typically messed with in terms of that. You can always go to recommended, and you can see that the main things that we changed are in fact right here in recommended also. They were altered, so it's like, oh my gosh, you changed it. Of course I did. I changed it because I wanted the temperatures to be a little higher. You can see temps aren't listed here, but our infill density is. We selected gyroid, and our shell thicknesses, sides, top, and bottom should be 0.8 millimeters. 0.8, all right, is what you need to have those at. And then if you want to go to the temperature thing, click custom here, and that is all available within all of this stuff. So as you're kind of going along, you start to kind of learn like how these things are going to work, temperatures under materials. All right, so I think we're all set here. So as long as those things have been changed, we're able to slice this. Now, when you slice this, let me just bring this window up so it's out of the way. Nothing really happens. It's not crazy. It's not mind-blowing stuff that's happening here. It just effectively is going to change to a save setup. So I'm going to go ahead and slice now. So I'm slicing process. You can see it'll tell you approximately how long it is going to take to print. It tells you how much plastic you're going to use, and it tells you the cost of that plastic. So this particular part costs about 30 cents to print. Now you might think, oh, that doesn't seem like a whole lot, but let's say that you are a company, and we'll just use this as an example, and let's just say, as an example, we'll start off with a real basic number here. So if it costs 30 cents to print, and we print 100 of those, there's our cost, $30. Oh, that's no big deal. Well, let's say that we increase that now. So we'll go to the next kind of level here, again, 30 cents to print. Let's say that we're going to print 10,000 of these things. So now it's costing the company $3,000 to print 10,000. But the reality is you probably want to print, I don't know, several 100,000, right? You're going to sell this as a product to everybody all over the world. These clamp feet, they're just the most amazing thing in the world. So at 30 cents, it's going to cost our company, and again, we'll multiply that. Let's say we're going to do 750,000 of them. So there's our cost just to print the plastic. That doesn't cost for the machines, the electricity, the people that have to do this, the designers. So the material alone to print a quantity to sell to the world, about $225,000. All right, so when you start kind of adding up what this is going to cost, it's to print one piece doesn't seem like a whole lot, right? 30 cents. But to print up a quantity worth selling to the world, we are going to have a fairly serious amount of investment cash in just plastic alone. So there's that. Anyway, let's get that off the screen. So the last thing I'm going to do is I need to save to disk. That's what we're going to do here. So you're going to click that, and it's going to bring up this little window here, and you are going to, and this is a G-code file. So it's a different file than what we initially created, and you'll see it has attached, there's your clamp foot T, that was the name of my file, but it has attached the CE3V3KE to it, which indicates that is the file that we will use that will go to the 3D printer. So it makes that 3D printer, of course, here I would go to my network drive, you would go to your network drive, and you would save that. Now what you're going to do with that file after is you're going to submit that to Google Classroom, and I will be able to download that onto a USB drive, and I'll plug the USB drive into the printer, and hopefully, if everything's good, we'll print up your file or files. You may have multiple parts. Some of you are going to have multiple parts just because of the design, and so you'll have to send me all the files associated so that I can print those up. So I would hit the save button and then find that file. So I'm going to put mine on the desktop, as you can kind of see here. So there it is, blah, 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 clamp T, going to hit the save button because that's the file name it wants to use. And we're done with Cura now, so I'm going to just minimize it. And we'll minimize that, and we'll minimize that, and that, and that, and that, and that, and that. And here is our file right there, as a matter of fact. So that should give you an idea of the process that you have to go through. So so just so everybody can see, down here, that is my Inventor file. This one is the file for Cura. That is called the STL file. And this is the file that I will use to print my clamp foot from. You can see it has attached the printer and kept the name of the file as well. So when you are done for each part, so if you only have one part, you're going to have 3 files when you're done. Inventor file, IPT, Inventor file for Cura, which is the STL. Go away. That's the STL file, and then the file that Cura will create for the 3D printer. So if you've done this correctly, and again, this is just for one part, you'll have all 3 of these files here, and that's basically where things will be kind of finished up, and we can actually create this. So hopefully this will help you to get through processing the file, putting it into Cura, prepping it for print, and prepping it so that it goes through properly. Because this file right here has all the information, the temperatures that we need, the thicknesses of the plastic, the type of plastic, and the type of printer. So as long as you did all of that inside of Cura, you're good to go. So hopefully this will help you today as you go through the process of converting from your IPT file in Inventor. You are going to need Inventor open to start, to getting it to a printable file that I can utilize for the Ender printers. Okay.